Good morning. Welcome back to our Economics of I/O of Regulation course. Before I start, I just want to draw your attention to the seminar we are going to offer in the winter term. We are offering a seminar on competition policy and regulatory topics with respect to the COVID-19 pandemic. So I think just go to the, oh, actually I could do that. Just go to our chair's webpage, and there you can get further information. We are going to discuss topics like how efficient Germany or German federal states run the vaccination campaign, what happened in terms of procurement of vaccinations, and so on. So just look at it. We hope that, or we are pretty sure that we get a rather interesting seminar. Okay, so without further ado, I now just want to start with economics of regulation. First of all, please join me in Webex and for any questions and comments. And if there are any problems, also tell me that in Webex. Okay. Welcome back to our economics of regulation course. We are in the midst of the discussion of regulation under moral hazard. And I think pretty much what we ended with was this slide in last week. The starting point of all this discussion is that the cost of a firm depends stochastically on the effort of the firm and of its managers. As a consequence, the regulator, even though she can observe whether the firm has high costs, doesn't know whether the costs are high or low, or whether the costs are high, for instance, because the firm didn't work hard or because there was an adverse environmental shock. Okay, that's our starting point, and what we need to find out is the optimal regulatory mechanism, or the optimal contract, so to say, if we want to tackle with this problem of asymmetric information, with this private information a firm has, as only the firm knows how much how hard it worked and how much effort it put into. The regulator is assumed again to maximize expected consumer surplus, and what I already told you last week is that here we have to put the firm's objective not in terms of its rent, but in terms of its utility. I explained to you that rent and this utility are different from each other, at least as soon as we allow for different risk attitudes or for something like risk aversion. And our starting point is, and that's what we have here, the regulator maximizes the expected consumer surplus, and consumer surplus, and I derived that in the last lecture, depends on the utility of the firm, and we just can put the utility of the firm, the rent of the firm in terms of the utility. So the point is that we can put the, and I think I just switch over to OneNote here so that you see that here is the example I used so that we saw how we can put, actually it was in this previous part here, where we derived the rent of the firm here. It's just simply pi plus t, but we know that the utility is here in this simple example just the square root of the rent, therefore we can, or we immediately know what the utility is, that R is equal to U squared, and that's how we obtain this relation between consumer surplus and utility, where we previously just had the relation between consumer surplus via the tax payments or the transfer payments and the rent. We now have this relation with the utility. Okay, so that should be clear. And of course, the regulator has to take into account the standard constraint. This constraint here is nothing else than the incentive compatibility constraint, which derives from the first order condition of the firm in terms of what effort it should choose, and that effort depends on this. In a sense, on this power of the incentive scheme, that is, what is the gain in utility if you get the good state rather than the bad, and then we can put that directly as the optimal function here, the phi. And remember that the firm in our setup just chose the phi, the probability that you get the good state. The harder you work, that's the simple or the assumption, the harder you work, the higher is the probability that you end up in the good state. Okay, and the assumption here is that the higher your utility gain typically is, the harder you would work. And of course, we also have the participation constraint, and we will get back to that in a second. And what we also played around with was already that we can reformulate that by using the participation constraint, just meaning that the expected utility is nothing else than the outside utility. That is, we add just 0 here if it binds, and therefore we can put all that in terms of total surplus rather than just in terms of consumer surplus, and that's what's written here. So the welfare is just the expected total surplus. Of course, we then have to take into account this utility from providing effort, and here we just define total surplus as consumer surplus or plus firm's utility. So, and I think this was actually the last slide I did with you on last Thursday, without, however, discussing that in detail, and that's what I want to do now. So we first look into the full information outcome. What does it mean? The firm, the regulator can really observe how hard the firm worked. And if it can do that, it can, of course, just say, okay, you work so that we obtain this phi here, and therefore the regulator directly controls the effort, has to choose then in her maximization problem effort and the utilities, and of course always have to observe the participation constraint. And so this is just what we just derived, okay? We maximized total welfare, and total welfare is just expected welfare minus the utility from work. And we put that now in terms of Lagrangian, because we have to satisfy that the participation constraint is satisfied. And here the participation constraint is in some detail here. It's just the expected utility. Remember, we had this discussion of the Neumann-von Morgenstern utility function, von Neumann-Morgenstern utility function, of course. And that's what we had as a participation constraint. Here, the point is compared to the adverse selection model. Here, we have a single firm, not two types, a single type, and we control, first of all, the incentive. And here we don't get any rent, or we control the effort by observing incentive compatibility constraint, and at the same time we have to satisfy the participation constraint. In particular, in the case where we consider risk neutral firm, you will see that this works perfectly together. We can at the same time offer incentives and observe the participation constraint. Okay, so the first part here is simply the expected welfare, and the second part here is just the constraint. And here further on this is just for completeness, that we use this outside opportunity U0 without any restriction of generality. We will set that equal to 0 in the following part, just to have it once here. And the second line here is the standard kind of rearrangement Armstrong-Seppigen always do here. First of all, they add the U to the B in order to get the W, the welfare, and here we do it, we subtract it again and put that on the other side so that you get just an additional 1 here. Remember, we just got this expression by adding the participation constraint, and now we put that, just rearrange it and put it here. Okay, the point is that now it looks really very much like in the Ramsey problem, and the advantage is, as you will see, we can put the first order condition very nicely. Okay, so of course, once we know what our variables to optimize are and what our optimization problem looks like, we are happy, because we just can apply our standard differentiation, and we just obtain a first order condition. And that's what we are going to derive right now. So we have our 3 variables, phi, ul, and uh, and here just the derivative with respect to, it's my lines here. The derivative with respect to ul is straightforward. Here ul enters here and it enters here. Okay, so very straightforward. Phi times v prime ul plus 1 plus lambda phi, and analogously we get the derivative for the high cost utility uh, if high cost order outcome, and this looks completely analogous. And finally, we get the derivative with respect to phi. You see here, again, erasing that, the phi shows up here, and so we get the difference in terms of consumer surplus, and of course it shows up also in the constraint as we see here. And now so this is now a very general approach. You will see further examples in a minute. But what the nice thing is, and what economists always try to do, is they try to derive results as general as possible. And that's what we are going to do. What you see here you easily can just cancel out the phi, as you can cancel out the 1 minus phi in the next first order condition. And what you see is that v prime will be equal to minus 1 plus lambda, and v prime ul will be equal to minus 1 plus lambda, and the same holds for v prime h. Okay, and that's what's written on the next page. And that's what I just showed you, and both things are the same. And that means, in a sense, what is it? This is the marginal rate of substitution, or the marginal utility, in a sense, and the marginal utility of the firm will have to be the same. So again, I might just jump here again to our case, or to our example we had here. If you see, if you take just the derivative here, I'll just go here because that's today. If you take the derivative here of vi prime ui, okay, that's the vi. If you take the derivative, you just get minus 2. Here you should have it ui. Okay, and so that's what you see, and this is simply our result here. In our example, this would in both cases be just minus 2 ul equal minus 2 uh, and that therefore we immediately get ul is equal to uh. And what we had here in our previous example was that v of u is concave. That's exactly what I showed you, due to the concavity of ut, because the firm is risk averse. Okay. Of course, all of you are aware that concavity here for a function with a single variable just means that the second derivative is negative, and as the first derivative was minus 2u, and if we further derive it with respect, or differentiate it with respect to u, we get minus 2, which is obviously negative. Okay? U of t is, of course, u of the transfer here. Okay? Or just a von Neumann-Morgenstern function. So, important result, first order condition, these derivatives which just have nothing else than a marginal utility of the firm in it, they just are identical, okay? And as a result, we get that utility of the firm is the same in both states. Irrespective of whether we have high or low cost as an outcome, the firm bears no risk. The firm, being risk averse here in this example, gets complete insurance. Okay, that's the first important result. If you have, and that's what we assumed here, I don't know whether I mentioned it before, if you have, in a sense, a principal who is risk neutral, and we assume here that the regulator, and therefore also pretty much the consumers, are risk neutral, they will insure the risk adverse agent. Okay, here it's the consumers, because in Germany there are 80 million taxpayers, so you would hardly notice notice if there is a small change with respect to some transfer somewhere. Okay, to some industry. Okay, that was the first important part, and the second important part is our second condition we get here. And here in this condition we had it on a previous page. The only thing is that we had the 1 plus lambda there in this condition, and we just substitute here for the 1 plus lambda from the other first order condition, and we get here the other important result, which determines, in a sense, how high we should set our phi. And here on the left hand side you have the gain from increase in phi. This is somehow the marginal productivity of effort. Notice that here, if you have the low state, you have low cost, and therefore you will have a low price, and therefore high consumer surplus. And of course, this is a gain compared to the state in which you have a high cost, and therefore a high price and the low consumer standard. And so this is a gain from an increase in phi, because that becomes now more likely. If you have a marginal increase in phi, it becomes more likely that you get this gain. And on the other side, you have to trade that off with the higher effort you need. And this is just a derivative of this utility function, and in a sense this is slightly compensated, because it gets a slightly higher chance now also, the firm, that it gets the higher utility ul compared to uh. However, as we previously saw here, and that's the last bullet point here in our case, if we fully insure the firm, there is a delta u, which is actually ul minus will simply be 0. So this effect just cancels out in the optimum. And finally, these v prime ul, here this is in utility terms, and we have to translate that back again into, say, monetary terms. As you know, even though utility is also just a real number, in our previous case, if the rent was 100 and we had utilities just the square root of the rent, the utility would have been just 10, and here we just invert that again, in a sense. Okay, yeah, that's our results, and what we are doing right now is first of all looking into the second best, so that this becomes clear, and then I will provide you some specific examples, and I hope that it gets clearer then, or it gets really clear after we have done that. Okay? Yeah, that's what we have done. So we will play around with these conditions, and then they should become clear. Apart from that, we will of course always also have a problem in the assignment here. So, and the nice or the interesting thing is now we have asymmetric information. So the regulator can only control the phi via the power of what we call the incentive scheme. That is the difference between this is simply UL minus UH. That's what I defined on the previous slide. Okay, and we know if we make this difference larger, the firm will work larger because in a sense it has more to lose. And here we implicitly define then phi just simply as a function of this power of the incentive scheme. And now this is what we derived just on the previous slide. Okay, or actually it was 2 slides ago. Our Lagrangian, our optimization function for the regulator, and it's exactly the same. Apart from the fact that now we take into account as a regulator that we control phi only via delta U, that is via the difference between UL and UH. Okay, that's what it is. Apart from that, it's straightforward. Again, we add here the participation constraint, and it's in this specific kind of Ramsey formulation in a sense. Okay, and now. And that's a nice thing. Once we know the optimization function, the Lagrangian, it's straightforward to derive our results. And therefore, of course, the real problem will then be to make sense, to interpret these conditions. So that's always what you always should do once you discuss some paper. The important point is not only the equations and the formulas, but the important point is what do they mean? Okay. Again, here we maximize expected consumer surplus. That should be clear with the probabilities. And then here we take the first order conditions. Now they look much more ugly than previously. Here, if we take the derivative to the second argument times the third, and remember that delta U is simply UL minus UH. So the derivative here of delta U with respect to UL is simply 1 here. And so we get therefore V prime L. Yeah. So that's what we get here, okay? Straightforward. And of course, the same thing for the high type here, only the delta, the phi, excuse me. The phi depends on delta, and similar for the participation constraint. Is also no problem, hopefully. So here, everything should be clear right now. The not so nice thing is that it really looks ugly, and if you look at it the first time, you will really have trouble to understand anything. Even though the first line here should be clear. Okay. Now the second line is rather interesting, because what you see here phi prime times UL. You have here phi prime. You have here phi prime. Okay. And if you just factor these together, these terms, you will see it's phi prime times UL minus, here's a minus UH minus D prime. Okay, but that's nothing else than our first order condition. I don't know where I should jump back, but that was our first order condition. I just look up where we had this first order condition. I think we had it on this. Here was the first order condition, and here you see D prime is nothing else than UL minus UH as an equilibrium effort, but that means simply that the terms I just showed you, they are 0, okay, they cancel out. And so this was this term, and this term. They are just 0 times phi prime, so that cancels out, and we get a much nicer condition. Oh, I wouldn't have to have jumped back because I had written it anyway here. But you get here in terms of what you get out as a derivative of the participation constraint is only what we would call the direct effect. Okay, times phi. Okay, yeah. But now already, and that's here you see why it's nice to put it in these terms of this Lagrangian approach with this 1 plus lambda. Again, you see what we can do is here you have the phi v prime of ul. And if you remember what we did in the full information case, we had that this phi times v prime l is equal to minus 1 plus lambda phi. Okay? That was our first order condition in this case. And now we just put all these other stuff here on the other side. And I think that's what hopefully I do on the next page. Here we have the VL prime UL, okay? And in the full information outcome, we simply had this point and or this term. And it was the same for VL and UL, okay? And now you see, now it's different because there's some additional term here. And this additional term here, just as a shorthand, remember, we just use the delta V is nothing else than the gain, in a sense, in consumer surplus from the good state, from the low cost to the high cost. Okay, and you see phi prime, the derivative of this utility or the optimization function here is positive. That is, phi just increases if you have high. That's our basic assumption. Okay, you work harder if you get more in a state compared to the other state. Okay, you provide incentive. Therefore, you have a minus here, so which is lower than. And similarly, of course, you have to take the derivative with respect, or to take the derivative of the Lagrangian with respect to UH, and you get this. And here you have something positive. Okay, so as a result, from the VUL, from the VL prime, you subtract something, so VL prime gets smaller to VH compared to the full information outcome. VH prime, you add something, so it gets larger, and therefore, as a result, you have that the VL prime is smaller than the VH prime. Okay, but that immediately means if VU is concave, and that's what we just assumed, that is, if our firm is risk averse, UL will be smaller than UH. Okay, and again, I think I always have to jump back to my diagram here. That's what you saw here. Here we just looked into the derivative, and of course the derivatives of this concave function are smaller once we get farther out here. Okay, that's actually what we have. Hopefully that's clear. That's due to this concavity. So UL will be larger, the derivative will be smaller, therefore UL will be larger if V prime is smaller. Okay, that's what we have. Yeah, and the point is now, no more complete insurance. The firm bears risk. We have a different utility, and of course a higher utility if the good state, that is the low cost turnout, than in the bad state, in which the high cost turnout. And therefore we provide the firm with some incentive, because of course if UL were equal to UH and the incentive compatibility constraint has to be observed, then the firm would just by assumption not exert any effort. Okay, that's our important result, and that's a very general, hopefully nevertheless it's clear. In the notes I gave you, just for the example I had in OneNote, I calculated this, and where you see it immediately that you have this difference. And what I do in the next slides now, and in the remaining, say, 10-15 minutes of this chapter, is I just give you some specific examples for a utility function, in particular for risk attitudes, and what then the relation is between this utility of the firm and the consumer surplus. Perhaps I make a short break here and ask for questions. Okay, also short break. I just wondered, because I spoke of some direct effect. So this is the current slides. I just want to draw your attention. So I spoke of this phi as the direct effect because all these other expressions here cancelled out, because this was the first order condition. Direct effect just means if you increase UL, remember our objective function is really the consumer surplus. You have to pay more. If you increase the utility by 1 unit, in a sense, you have to pay more out to the firm, of course, but that happens only with the probability phi, because that's a probability phi in which you get the good state, that is the low cost. Okay, hopefully it's clearer. If not, just ask right now in Webex. Okay, we move on with second best optimum under asymmetric information with moral hazard. Okay, we move on. So hopefully the next examples make this then more clearer and more illustrative here. So the first thing we start with is, in a sense, the easiest case, because you don't have a problem in terms of insurance. We assume that the firm is risk neutral, and of course we always assume here in this chapter that we can pay transfers. And then it's very straightforward. As in all of the previous case, the firm can either be in state L or H, and of course we get a respective profit then as a function of the price. Of course, the point here is now the firm or the regulator knows in which state we are, okay, and can determine the price. V of P is again the consumer surplus, and a small w is simply the total surplus. And what we know here is that the regulator sets some price which maximizes the total surplus, and of course that price will then be the efficient one price equal marginal cost. And of course, some further notation: if the regulator sets a price P and gives a transfer T, the rent is just R is pi plus T. I just dropped here the subscripts, it should be clear. And now the important point is here that remember, it was just a straight line, the relation between monetary income and utility in terms of risk neutrality. So we can simply set that U is equal to R, and so the setup is pretty much the same as we always had. And now here you again see very directly this relation between or why we can put this total or this consumer surplus, this more general consumer surplus, taking into account the transfer here, so the net consumer surplus from that market minus the transfer. And if we substitute from up here that the transfer is simply R minus pi, and we also substitute that, or that R is equal to U, what we get here is that our large V here, our consumer surplus, is just a function or related to the U of the firm, the utility of the firm, as it was just with the transfer, and the transfer directly relates to U. And here, in the case of risk neutrality, it's even a linear function. And so what we get here is, here is nothing else than our total surplus. And so we can put here our V of U, that's what we previously had, in terms of total surplus minus U. And what we define here is just the definitions as the notation, is that large W as a function of U is here just V prime. Remember, I don't know, did I write it here? No, I didn't. Remember that W was just defined as V plus U. Probably you won't be able to distinguish my U from the V, but that's what it's meant to be. Okay, and that's not a grader, but it's an equality sign. And that's why if we put this U on the other side, that's what we get here. Okay, so and now we just substitute the previous or apply the previous first order condition. Remember, we calculated this here. Remember, in the full information outcome, we had the same utility in both cases, and what we will look into, whether we can not have the same utility in both cases, but whether we can implement the solution of the full information case in terms of the phi, so that we get the first best, the full information phi in this case, the full information effort. And so our first order condition, remember, that's what we derived, hopefully you remember, was just this condition. So this is the gain in consumer surplus, and this has to trade off the increase in effort here. Okay, and now with risk neutrality, this is straightforward, because that's what I just showed you. The derivative is simply -1, so we can substitute up here, and so we get and substitute the previous things here we derived, and what we get here on the previous slide is this condition, and you'll see immediately that this UL minus UH cancels out, and what we get is that this is nothing else, and I think I have written it down here anyway. This right-hand side is nothing else than the marginal productivity of effort. That's what I already interpreted or told you before. So you see what is the increase in total surplus if we move from a state with high cost to a state with low cost. Okay, and that's simply the different triangles we have in terms of the different consumer surplus triangles in terms of our illustrations of our diagrams we had before. Okay, and on the on the left-hand side, you have the marginal cost of effort. What does it cost in terms of the firms or the firm's managers this utility if they have to increase the phi, that is, they have to increase the effort? And okay, That's what we have here. And here the full information outcome, if the firm is risk neutral, risk sharing is not important. It doesn't matter who bears the risk, as long as, in a sense, the expected utility is the same. The firm doesn't care for whether UL is equal to UH or UL is much higher than UH, okay, as long as expected value is the same. So, and therefore, risk allocation is typically also not determined uniquely, and all allocations satisfying the participation constraint are solutions. So if phi would be 1/2, and suppose this utility would be 0, of course it wouldn't matter whether you have a payment of 10 in a good state and a payment of -10 in a bad state, or whether a payment of 100 in a good state or a payment of -100 in a good state. In both cases, the expected value would be 0. Okay. Now, what we are, and that's what I already told you previously, we want to look whether we can implement this solution, the full information outcome solution under asymmetric information, and whether we, of course, whether we are able to satisfy the incentive compatibility constraint. And so that's what I will show you on the reminder, and in particular how that works in detail on the next slide. But here the point is, you have the delta U, which is nothing else than this increase in total surplus. The firm should choose phi prime. What you will see here, that actually the firm gets the full difference in this gain here. That's from our previous case we just had from our first order condition. That is that the VL minus PL. Yeah, this is just the definition we used here. Okay, and if we want to have the first order condition satisfied, that's what I think we showed here. Okay, the optimal condition or the optimal full information outcome is that you have determined the phi by this condition. Okay. And in order, of course, to get the respective solution in a situation of asymmetric information, you just have to pay or to give the regulated firm an incentive like this. So the delta U has to be equal to this expression, and that's what I just stated here. Okay, so the delta U has to be equal to this expression, because then from this it follows that firm chooses phi star. Okay, that's the important point. And now, so I have written that anyway here. Okay, firm chooses phi star. That's from our first order condition. And from the previous condition, which just read that VL minus VH is equal to WL minus WH minus delta U, if you assume this, of course, this is 0, and so the consumers will have the same surplus in the high cost stage than in the low cost stage. Okay, the firm bears all risk and obtains the total gain in the case in which we get the good state, and therefore the full information outcome is feasible. Okay, that's then once again just rearranged in the same way we had it here. So implementing this full information outcome, pretty much what we did here is what we just wrote, what we just derived. The point is here, and I don't want to go back because it would only confuse you, we already derived it. So what we know is that we have to set this delta U equal to this WL minus WH. Okay, that's what we have, because then we get the right kind of incentive. And the point is, of course, what we know is that the difference in utility has to be UL minus UH has to be equal to this WL minus WH. But at the same time is we know here that we get the right incentive, but at the same time we want to satisfy the participation constraint and don't want to pay any rent. And that means, so if this delta U would be 100, and we don't want to pay something, we don't want to pay any rent. We just have here, you see that's what in a different case your payment is. You get a transfer in a good state of, I don't know what consumer surplus is, 1,000 in a good state and 500 in a bad state. And of course, you get this difference here. But the point is that you have to pay, in a sense, a tax, okay, minus K. And K is chosen in a way that our participation constraint is 0 or is equal to U 0, and we have 0 rents. Okay, and that should become much clearer or should really become clear in the problem we have in the assignment. Actually, perhaps I just, if I'm able to find it, I just point to that. So what we do here is show how we can implement such a solution here in this example under asymmetric information for a risk-neutral firm. Okay, and that's where we have to calculate that. Okay, you will see that this is then actually rather straightforward. Okay, and the point is here, actually what we are doing is we make the firm the residual claimant on social surplus. Okay, we just say you get everything, you get this increase, in terms of consumer surplus fully, but you just have, in order to get a certain project, you get all the increase, but you have to pay something for this project. Okay, that's what we have. Yeah, and that's a nice thing. So what we learned here, and remember, risk neutrality is always a good thing somehow if you get some information. Here we really can implement the full information outcome, even though we have asymmetric information. So we can get the right incentive, even though, of course, now the rents are the transfer are slightly different than in a full information outcome. There we assume that UL is equal to UH, but the point is here it's only the expected utility which matters. We have then therefore a really high-powered incentive scheme. High power just means that we get quite different payment if you realize, or if the good state is realized rather than the bad state is realized. Okay, and of course it's a problem in a bad state here. Exposed, you might end up, even though you worked hard, you end up in a bad state and you make losses. Okay, that's this firm has to be able to bear these losses, and that's what we will turn to, I think, in the next but one extension of this, where we look into limited liability. Okay, now the second point is the risk aversion, and here assume simply that u is some function of ur. So what we used in our example was that this small function u is just a square root in a sense. Okay, and this is what we had. This would be concave. That's the example I told you, and so this is just the inverse. This would be the square. And that's what I just showed you on our previous slide. Remember, that's what we had here as an example. And now we have this concave relation. We get what we had here in the full information outcome. That's what I already told you. This is nothing else now, or nothing new. That's why I don't need to spend more time on this. The important point is that the full information solution would give you very poor incentives, because you get the same paid irrespective of your effort. So why should you provide any effort? Okay, and the second best policy, and that's what I told you already, is that you give incentives. UL will be higher than UH, and therefore VL of UL, or however VL of UL will also be higher than VH of UH, and that means here you remember on the previous slide we had that this part was equal. Okay, we had put so high incentives that this part was equal, but here it's less. So we have lower powered incentive than in the previous case. So we provide incentive, but we provide less incentives, of course, than in the case of risk neutrality. And the greater risk reversion is, the lower powered are these incentives. If you have infinite risk aversion, so that the utility is the same, if you get 2,000 euro per month or 3,000 euro, the utility is always determined by your minimum, then you wouldn't give any incentives here. Okay, that's what we have. But that's exactly what we already derived. I think we don't have an example on that because it's so tedious to calculate, and it's hard to do without any Mathematica. But okay, very short break. Not a break, but I just I don't know. Probably you cannot read here what I wrote in. Probably I should try to enlarge it here. Text should probably be something like 36. Can you read? Oh, make it even larger. That's 28 here. 48 is too large. So the point here is, with the second best policy, I told you that you will provide incentives. That is, UL is larger than UH. But the problem is that it's not as large, or the point is that it's not as large as in the case with risk neutrality, okay? Because here you have to observe this point that you have risk aversion, okay? So you are just halfway between a full information outcome, where UL is equal to UH,
and VL is larger than VH. Okay, so that's our second line, and the risk neutrality outcome where VL is equal to VH and UL is larger than UH. Okay, so that's what you have, and so in a sense, that's what is so interesting about comparing the full information outcome with the risk neutral outcome, because there you have the same phi but rather different effects in terms of VL and VH. I don't know whether it make it clear, but I tried. Okay, so we move on.
What we have an example, and is the final case we consider here. This is risk neutrality with limited liability. That's something we already briefly discussed in an audit case. Of course, what we see here or what we saw in the previous case where we implemented the full information outcome, in a sense, we provided a high incentive in a good state, but that means that we have, in a sense, a high loss in a bad state. And high loss in a bad state means that these firms can capture or cover losses in the bad state. And that's not clear that this is possible. So if you have a firm with limited liability, you cannot have a rent exposed, which is negative. Okay. Of course, ex ante, you might have a rent of 0, even though you get 1,000 in a good state and minus 1,000 in a bad state. But the point is, can you cover these losses of minus 1,000 when the bad state turns out? And here we just assume that you can't do anything, cannot receive a payment or receive anything which leaves you with a rent which is negative. Okay, so RI has to be non-negative in each case, and therefore in a bad state, in a high cost state, you assume that RH is equal to 0. Now, if you want to provide incentives, you have to pay a rent in the good state if it turns out to be a low cost firm. Okay, and of course you see this being 0, this being positive, the expected value will be positive. And the firm's overall rent here is then phi times RL minus the phi. We assume here with these values, and I think that's what's the last bullet here, that this value is so high that the ex ante participation constraint is not binding. So this rent is sufficiently high that phi RL plus 1 minus phi RH minus this d phi is larger than 0. Okay, now the firm enjoys a positive rent. And again, of course, the difference, the delta U, this is nothing else than our delta U here, is just RL, the difference in terms of utility, the power of the incentive scheme. And the regulator now needs to maximize pretty much the same as previously, but now we have to take into account, we have to pay here the rent. And again, now once we pay a rent, our alpha matters. Okay, that's here and here. Okay, because we have to weigh that, we typically assumed or very often assume that alpha is equal to 0, so we don't care for the rent of the firm. Of course, nevertheless, we have to pay it in order to provide an incentive. This would be just here the standard. This is nothing else than our T here, okay, our transfer. And that's our standard setup. Again, we maximize expected total surplus and taking into account that if the good state turns out, we have to pay a rent. Okay? That's what we have, and we determine this rent up here. And yeah, so for this RL, we simply can substitute the d phi, the d prime of phi, yeah, that's then in a sense straightforward, because then we get as an objective function, and this I just updated this in your slides. It will be slightly different because you will have the RL still here, but it's easier to see then if we take the derivative with respect to phi, what the first order condition, what the optimal condition is. Okay, and here you see taking the derivative with respect to phi, you would get a d prime here, take a derivative. Here's a phi, okay, that leaves you this here, and then that here you get then also the second derivative here. So it's straightforward to derive that. You see here you have an alpha d prime phi if you take the derivative with respect to. So what you do here is dw d phi, okay, and from that this follows. Should be clear. And so you get all, if you take the derivative, you get all this here. And important point here already, you see that now you're already trained. to look for common patterns. Our previous pattern in full information outcome was that d prime is identical to this gain in total surplus. Okay, and now you have an additional negative thing here. D prime prime, D double prime is positive. This disutility from effort is increasing and convex. Okay, the more the more effort you have to put in, or the higher the probability is you want to achieve, the more it costs to get an extra increase in this probability. So you subtract something, and therefore you get, with limited liability, as we are here, you get a lower incentive. Limited implied. And therefore, limited liability implies less effort, and because you get a lower powered incentive. Unless, and that's what we always have, unless you don't care for the rent, and if it's clear, if you are happy to provide a rent, and alpha is 1, so you get the same. Okay, I think that's almost it, because now we have really derived our result. Okay, and there's actually a case with 2 stars in the problem set. Perhaps you can look into that, where you really see how this changes, how this limited liability problem changes this nice result for the risk neutral firm. You will see now, once you have risk neutrality, it's not about insurance and incentives. That was in risk aversion. Okay, so if you provide incentives, you have to pay that, because then it gets very expensive, because the firm has to bear risk if it's risk averse. Okay, and that's why you have only limited incentives. And here, however, the point is you provide incentives, but you know, if you provide incentives, you have to pay a rent. Okay. This is different from the previous case with risk aversion, because there you always satisfy the participation constraint and you don't pay a rent. But here you have to pay a rent, and you want to limit the rent, and that's why you provide a limited incentive. Okay, I think that's about it for this moral hazard part. And here, this is the last slide of these chapters on asymmetric information, on adverse selection, and on moral hazard. And what we saw is, first of all, that's a pretty standard assumption, which I already tried to motivate in our very first lecture, where I showed you this Australian case with the different information or different cost estimates of the regulator and the regulated firms. And the point here is what we learned: if you have private information, if you have superior information about your cost, about marginal cost, fixed cost, remember all this, Baron, Myers, and Lewis, Sepping, and Lafont-Tirol, and so on. If you have this cost advantage, you can command the rent of it, because if you are the low-cost firm, for instance, you can just always claim to be of the other type, and therefore would always get a rent. So, and the point is here, I think I'll probably go to the next 2 bullets here. Of course, you get this rent. What you want as a regulator, and that's what I showed you with the revelation principle, and that's what's always optimal, is that it's good if you design a contract in a way that you induce truth-telling, okay? And therefore, because therefore you can realize Pareto gains, you can realize a higher welfare, okay? But at the same time, you want to limit this rent, and that's actually what we do in the next bullet here. You induce outcomes which somehow distort the decision. They differ from the outcome we would have under full information, and that's in particular in terms of, remember Baron Myers, and the price of the high type is distorted upwards, is distorted away from the marginal cost. Okay, and these distortions, as previously here in the last case, serve to limit the firm's rent. And finally, we had some discussion of say, for instance, of capture and of dynamics and commitment. Of course, the important point is that we need to have a benevolent regulator, and a benevolent regulator is better able to limit the firm's rent if he or she is endowed with a broader set of regulatory instruments and more extensive commitment powers. Regulatory instruments, we saw that was in the very beginning, of course, that you don't get a very good result if you, or a worse result if you cannot pay any transfers. Okay, that was the first part. If you can't pay any transfers, you always have to observe the non-negativity constraints, so you run into troubles. And of course, commitment we also discussed, so I don't want to spend much more time here. And this was the very final point. If you have limited commitment power, you might even choose a pooling equilibrium. Okay, I think I'm done with this part. I'm just making a short break here and move then on to chapter 11. Yeah.
Okay, we make a break here as well. I think last year I made a really brief cut here. you really have, so this is just the overview slide, you really have deserved a break because you managed to go through all these modern topics of incentive regulation, regulation under moral hazard, regulation under adverse selection. So these asymmetric information problems, and these are really tough ones. So you did a good job, and now your task, of course, is to solve the problems in the tutorial class, and in the end, of course, also in the exam. Okay, short break here, and I'm available for questions in Webex. Okay, welcome back. We move on with our information and multiple firms yardstick competition. Important topic in actual regulation, as you will see.
Okay, so of course, this was a very tough topic, or were very tough topics, this regulation under adverse selection and under moral hazard, and fully it will only become clear once we discuss all the different problems in the tutorial class from the assignment, and therefore I hope that it becomes clear there. And of course, we also can take many of the questions you might have also in the tutorial class. Now I move on to something which hopefully is less abstract in a sense, and in a sense is also formally easier to tackle. We move on to information and multiple firms, to what is called yardstick competition and monopoly franchises. The problem is always how can, or the starting point is always how can the problem of asymmetric information be mitigated in a situation in which it's clear that we have a monopoly in the market. We will only have a single firm in the market. So as I think Demsetz called it, it's not possible that we have competition in the market, but if we do not have competition in the market, we might have, first of all, competition for the market, which is actually the first part. We have multiple contestants for a monopoly franchise. That's what we see, for instance, in railways, where we have now always a single firm being active or providing a certain connection. Southwestern Railways in UK provides some connection in the vicinity of London, whereas here HLB, Hessische Landesbahn, provides a certain connection from, say, Frankfurt to Gießen, and there is just an auction where they have to apply or to submit the tender a bid in order to win this tender. We might, however, also mitigate our asymmetric problems if we have multiple monopolists, but multiple independent monopolists, and that's the first part I turn to then. What you will see is that there are at least two benefits of multi-firm supply. The first is what I think Armstrong-Sappington call a sampling benefit. That is, you have a greater chance of finding a low-cost firm. Of course, that works only if you have multiple contestants. So it's more likely if you have 10 firms applying for a certain regional public transport system, if you have several applicants or several bidders, your chance that you get a low-cost firm is higher than if you have only a single one. Okay, that would be the sampling benefit. The second benefit, which matters in both situations, is the so-called rent reducing benefit, because now the private information is reduced, and therefore you can reduce the rent. And the point is, that's what I told you, these benefits can even be seen in the market if competition in the market is not possible, but competition for the market. Okay, that's an important for the market. That's an important point. Even though competition for the market actually, in a strong sense, only applies in this case. Okay, yeah. First of all, I want to turn to this part here, multiple independent monopolists, and the German electricity system is a really good example of that. In particular, if you look into the electricity distribution system operators. So we have, these are all so-called Stadtwerke, so municipal electricity companies largely, and here you see the efficiency estimates for 179 different German electricity distributors. I think here's even Mittelhessen-Netz, which would be some, I think is even a subsidiary of Stadtwerke Gießen. Okay, and what you have here is, of course, if you have only a single monopolist, this and you cannot directly observe its cost, it's hard. You don't know, is it high or low? But now you have these 179, and you might be able to compare them. Okay, you will see how you can implement something so that they reveal their information. Actually, what the Bundesnetzagentur, the Federal Network Agency, does, they compare these different companies, and even though they did not implement some benchmark or yardstick regulation, what they do is they look into their costs and tell them, this guy here, okay, you better increase your efficiency, because otherwise you will have you will not be able to cover your costs because the network charge we allow you will not cover your costs because it's based on efficient costs. Okay. Actually, in Germany, and that's what you can read in the note, we have, I think, more than 800 of these German electricity distribution system operators. But as you see, more than 600 are small, probably smaller than, I think, something than 30,000 households or something like that. And they, for them, a simplified regulatory system applies, so they don't have any efficiency estimates. Actually, there is some standardized some lump sum or some average estimate for that. Okay, so the point is here, now we have these 179 different German electricity distribution system operators, and Andrzej Schleifer came up with a very nice model where he showed how we can, or how a mechanism can look like, so that we can produce competition among these independent monopolists. Okay, that's what we actually do, and so that we can even achieve the first best solution. So what we assumed here is, or what Schleifer assumes is, that we have an identical local monopolist. Of course, in terms of our German DSOs, distribution system operators, they are heterogeneous, but for the minute and for the sake of illustration, assume that they are identical and they each face the same demand, and they each have chances to reduce their costs by making investments. Okay, and if they don't make any investment, they are stick with some high cost level. The point is that we assume that the regulator doesn't know anything about their cost. The regulator doesn't know demand and doesn't know these investment function, but it can observe the realized costs and the realized fixed cost and the realized marginal cost, and however can only observe that afterwards and doesn't know these investment function. Okay, doesn't know whether there would have been possibility to have even lower costs. In a sense here, it could only observe, oops, I was too quick again. It could only observe this point here, okay, ex post, but didn't know whether this is really the efficient cost or not. Okay, but that's what the regulator can observe. Okay, so what are we doing then? A further important assumption is that the firm's managers maximize profits, but as long as profits are not at stake, they exert as little as effort as possible. What does that mean? Now, it means that if the regulator sets price equal to these observed marginal cost and transfer equal to the fixed cost, what is your profit? Your profit would be zero. And if you work harder and you get a lower marginal cost here, again, and higher fixed cost, again, your profit would be zero. So why should you work hard and think about these investment projects? So you always have the same profit, so you don't exert any effort with if price is set if price is just set equal to marginal cost and the transfer equal to fixed cost, so you don't invest. Okay. That's what I gave you in the notes, the respective explanation by Schleifer, but I think the basic point should have become clear. So the firms would not invest in cost-reducing activities. And that's similar to what we had in terms of our cost of service regulation. So if you just get your cost recovered, why should you work hard to reduce your cost? Okay. Now, the very nice idea by Schleifer is that you can even attain the full information outcome with the following policy. And the point here is you are Stadtwerke Gießen, PI, and your price is set according not to your own cost, but to the observed cost of all others. And your transfer is set according to the fixed cost of all others. And now, of course, your profit is at stake, because if others first of all, price equals marginal cost. That will be the result. But the point is, how does that mechanism work? Now, if all others don't do anything, if all others have a C of zero, you can increase your profit by investing, because then you will have the price just equal to being C0, but your cost will be lower, even though your fixed cost will be higher under some regularity assumptions on F, and that's what you will see in one of our assignments. You just get an incentive to invest. Okay, you now really compete against these other 178 companies. Actually, the Bundesnetzagentur, the Federal Network Agency, when they first presented their concept for incentive regulation, they said, you remember that we have these 5-year incentive regulation periods, and they had plans for the first period and the second period, and they had a plan in the third period to implement this kind of yardstick or benchmark regulation. Okay, and the point is, you really come up with a very nice result here in equilibrium, the full information result, because in a sense you produce a prisoner's dilemma among these firms. They all have to invest, and they will invest so much that price equals marginal cost and productive efficiency is achieved, and so you don't get a profit. The problem here is, why are you forced to do that now? If the others invest, you would make losses. Okay, and managers don't like losses because they might get fired.
Okay, before we move on, I don't know, did I explain to you this notation here? Okay, with this J unequal to I, so hopefully this should be clear. The price of firm I is set according to the average of the costs of all other firms. So I just sum up the costs of all firms. J, suppose this is 180. So I would, and this is firm 25, then this I would sum up from 1 to 180 just without this firm 25. And of course, then I don't have 180 firms, but 179. Okay, so should have been clear anyway, but in case it was not, I just hopefully made it clearer. Okay, and here you have a high-powered incentive. The firm has no effect on its price and the transfer it's get, but the firm is a residual claimant of its profits. Okay, and these profits, if you work less hard than the others, it's negative. Okay, you get fired, and that was this basic assumption by Schleifer. So you care firms managers maximize profits if that means it changes anything. Okay. If you get zero profit anyway, you don't do anything, but here you might run into trouble. You can make even losses, or you can make profits. Okay, so hopefully this is clear right now. You got some idea. Actually, it's rather straightforward to calculate, even though the calculation of the Nash equilibrium is a bit harder. But what we do in our assignment, and that's what should become clear. I just jump here to my assignment. We have a very nice result here. You see a country with 100 regions where you have different periods, and in the first period the regulator sets the price according to the cost of the previous period, and then you just look or calculate what the optimal investment of these firms is. That's what you can do, and you will see that it's rather straightforward to calculate that. Okay? Yeah, so, and that's a nice thing. By doing this, you really can implement first best. And here you have, of course, not the sampling benefit of competition, because still you have Stadtwerke Gießen as a monopolist here, but you exploit the rent-reducing benefit. Because if these firms are all identical, they have the same opportunities for cost reduction, you can introduce competition among them, and therefore really here in this case drastically reduce the rent. And the problem, of course, is if you are then Stadtwerke Gießen and you are compared with the NWAG in Wetzlar, the Stadtwerke Wetzlar, the municipal electricity and gas company there, you would say, oh, Wetzlar is very different. Actually, Wetzlar would say that, oh, we have such a hilly city, so much rocks and so on, and it's very hard, for instance, to dig or to put the water pipes in the ground and so on. Okay, so you have the need for symmetry, and that's somehow also the problem for the regulator. Actually, in terms of regulation of water prices in Germany, we don't have an ex-ante regulation of water prices, but we have an antitrust overview, so to say, by the Bundeskartellamt, the Federal Cartel Office. And what they actually did is they enacted a few proceedings, or they started a few cases against German water companies and accused them of abusing the dominant position and charging too high prices. Actually, a famous example here was the NWAG in Wetzlar, the Wetzlar Water Company. Okay, and what they did is they compared the water price in Wetzlar with the water price in other municipalities. Okay, of course, it's always a problem. Is that really a good comparison? And there is no uncertainty in this model, but I don't want to discuss that here any longer, because if you have some uncertainty, you might also always run into trouble with this limited liability problem. But here, the argument should have been clear. There is another version of this Yardstick competition problem. That's a so-called reporting version. And here the point is that you ask your monopolist what the costs are, and the costs are correlated. Suppose we have Marburg and Gießen, the water companies, or actually the previous example was Wetzlar and Gießen. And if we assume here that if
Gießen has low costs, it's the probability that Marburg has Wetzlar has low cost as well is phi L, and the probability that Wetzlar has or if Gießen has high cost, the probability that Wetzlar has low cost is lower. Okay, and that will immediately remember you of our audit analysis. Okay, exactly the same argument. The point is here just here you have two different municipalities or 179 municipalities, and you ask them what their costs are, and their costs are correlated. Of course, so the signal is informative. It's more likely that firm B reports being low cost if firm A is low cost, if it reports truthfully. So we have a correlated signal of A's cost. We get some idea. Now, the point is, how can we get firm A to report truthfully given firm B reports truthfully? And now this is just standard. You have just some transfer payment, exactly the way we did it in the audit analysis. So if B reports to be of low cost and A reports to be of high cost, then you get a certain transfer, which actually would be the punishment. And in the other case, you get the other transfer. And as you saw, if you have limited ability to punish the firm, you can implement first best. The full information outcome is an equivalent. And you get, again, the rent reducing benefit of competition. Okay. The problem here, however, is the guys from Wetzlar and from Gießen are not stupid. They will just meet and say, oh, it's a bad idea if you report low cost, because then I will also have to report my low cost, and we both don't get any rent. Okay. And there is therefore the danger of collusion. Both firms always reporting high costs. How can you deal with that problem? Actually, what you could do is to write better contracts. You might write a contract that you get a bonus as a firm if you're the only one to report low cost. And that could destroy these collusive equilibria. Okay? Again, so how well it works is always unclear, but of course you could say you get really a high millions of bonus if you do that. And of course in equilibrium, as them both have an incentive to report these costs, you will end up, if they really have, okay, you will end up with not making a payment, okay? So, and of course, the same problems apply as with the audit analysis. If it requires risk neutrality, and it requires that you are not in a scenario of limited liability, that is, you are able to bear the large penalties. So we have two very nice situations in which we don't have competition in the market, but we have multiple independent monopolies and still implement, in a sense, the first best. We learn from the different monopolists. Okay. Now we move on to the second point here, to the second part, namely auctioning monopoly franchises. Now we get to competition for the market. And this is something which gained a lot of prominence in the last, say, 20 or 30 years. Here you see an example from Munich, whatever S-Bahn München is, a local public transport, and there was a tender for this. So Vergabe means just a tender. They invited bids for the S-Bahn, and of course Deutsche Bahn will do that, and some other companies. What you have here currently, I think here you see the timeline. I don't know whether they already finished, but you see this is quite a lengthy planning period. Currently there is a construction going on, there is installation, and then finally there is an operation. This would be a further line, a further train connection here, and you see it only starts, the contracts will only start in the 2030s, if you can read that at all. Okay. Oh, does it work? Yes. Here it only starts in the 2030s. Okay. And it's rather lengthy planning periods. And what you also have is that you, of course, need rolling stock, etc. And what is interesting here, how do the contracts look like? And what you see here currently, there are so-called, I think I already explained that to you, net contracts. And for later on, it will be gross contracts with incentives. Gross contract just means that the firm doesn't get any ticket revenue, passenger ticket revenue, but they just get their costs reimbursed. The costs they just, in a sense, a bid or submit as their bid with a net contract. You only paid the difference. You actually say part of the cost because the company, the railway company, obtains the ticket revenues. Okay, I don't want to go into details, but if you happen to run across something like Nettovertrag and Bruttovertrag, you should have an idea what this means. This is also can be seen in the UK, where this is now done for many more years, and you see they also have rather long planning periods. I also try to increase that here. You see it sometimes stops, and then you have HS means here you award the contract, here you issue the franchise, you invite for tender bids and so on, and then this starts, and sometimes it ends. And what you see here, these so-called franchises, they are valid for 10, 15, and 20 years. Okay. And see, so I probably should go back here. Here you see just East Anglia, here you see just which routes we have here, Southwestern, etc., Essex, Thameside. So here you see all these different connections and different franchises. And what they have is they just invite for tenders here. And of course, you can, even though a monopolist runs then this service or operates this service, and still we have ex ante competition. Okay, that's what we have. And that's what we are going to look into formally, how you should structure that. And here again, assume we have a Baron-Meyerson framework, because that's always the easiest. But now the point is that now there are n firms, and each of these firms might have either low cost with a certain probability phi or high cost. And you assume that costs are independent, not correlated as in a previous case with these yardstick competition, but here so you don't have any yardstick possibilities. And the regulator wishes to choose one firm to supply the market, and the policy takes a form that should be clear. If one firm announces it has low cost, the franchise is awarded to that firm, or if it's two firms, each firm gets a 50% chance. You just throw a dice, okay, or a coin. And if all firms announce they have high cost, again, you award the contract to any firm at random. Again, you roll a dice or something like that. And in the event that a type I is the winner, okay, if that firm tells you it's low cost, you will set the price even to PI and transfer even to equal to TI, and that's what we now have to calculate, what the optimal price will be. Okay, you will see we'll also have, like in Baron-Meyerson, always if you have CL low cost, you will have PL, but you receive a rent, and you will have some distortion if you have a high price. Now, I don't want to go through the detail or through these calculations in too much detail, just to give you the idea. So assume that the other firms announce their cost truthfully, and you are of a low type. Otherwise, you don't have to think about claiming to be a low type or cheating if you are a high type. And if you claim to be a high type, okay, that's how you would earn then a rent. The problem is that you only earn or you only win with a certain probability. Okay, in the other case, if you claim to be a high type, you are the high type and you get the franchise. But here, all others have to be of a high type as well. And this is just 1 minus phi, the probability that you're a high type, that everyone in this independent setup is a high type. So it's just raised to the power of n minus 1. And as it's awarded by random, it's just divided by n. And if you're a low type, you also have a chance that others, if you announce that you're low type, that others gain this. And this is actually this expression. And what you also can show is that this expression is larger than rho h. Okay, and so I don't want to go to detail, because here from this lemma from Armstrong's Review of Economic Studies paper, you see that it's not so trivial. So it would, and I don't expect you to calculate it. I just want to show you the idea here. What is clear? This is the rent, and the important point is here. That you get this rho L is greater than rho H here. The point is, of course, it's clearer that you win. You get this RL times rho L. This is, in a sense, the expected rent you get if you tell the truth. And here is the expected rent if you claim to be a high type. And you saw previously, this is our standard. I always speak in terms of rectangles. This is our standard rectangle. RH would be 0. And now our rho H is, of course, smaller. Actually, that's an important point. It will be, and that's what we will see in the next. I think it will be smaller than phi somewhere. Okay. So the point is that you get a lower. It's easier. The incentive compatibility constraint is relaxed here. Okay, because you get the phi. You see here you get the phi, and what we can show, and I didn't do that here, but this thing oh no, the important point here is with RL, this expression was just 1. Okay, you just got this for sure. If you're low type, you got this for sure. But this, as rho H is smaller than rho L, this expression is smaller than 1, and that means you now don't get if you're a low type, you don't get that rent for sure, but only with a chance which is lower than 1. Therefore, you have an lower expected rent, and therefore your incentive constraint is relaxed compared to the single cost case. You have to pay a lower rent, and we have a rent reducing benefit of competition. Okay.
Okay, you saw that I had a problem understanding my own slides, but after all, I managed it, and hopefully you understood it. It's actually quite easy because it was written there anyway. It was this assumption that rho L is it smaller or larger? I just have to look it up. That they are different, okay, and therefore we get this result immediately. So rho L was larger than rho H, and therefore this was smaller than 1, and you didn't get it with certainty in a sense, or with probability 1. Okay, so hopefully this was clear.
And now what I did here, and what I did here, or actually Armstrong did here, just calculate the welfare. And this is really our standard welfare function in a Baer-Myers model. The only difference now is here, okay, RH will be 0 anyway, so we can set that equal to 0, and this should probably write as an alpha here. But the point is, now we have different probabilities here. Now this is the probability of having at least one low type firm. And of course, this probability is simply what we have here, 1 minus phi raised to the power of n, is simply the probability that all firms are high type. So 1 minus this is the probability that we have at least one firm. And the point is that this is now higher than phi. That's what also can be shown. And again here, this is of course smaller than 1 minus phi, because 1 minus phi is smaller than 1, and if you raise it to some power of an integer, it will be smaller. So now what you get is a higher chance, and this is the next benefit of having multiple potential suppliers. You get a higher chance that you get a low-cost firm, and this would be the sampling benefit. Okay, of course that's what we always have in the standard results, and you can look at. I just jump over that rather briefly. We won't do it in detail because these. The derivation of these laws is quite complicated anyway. But what you see here, and what is the important result here, you maximize something which is completely analogous to our standard Baer-Myers case. And actually, the strange thing is, even though it looks different, you get the same result. You get exactly the same result as in Baer-Myers if you compare that to the previous part. And so the point is, why do we get that here? We have to pay lower rent. Why don't we reduce the price of the high type? The problem is we have to pay lower rent, but it's a higher probability with when we pay this lower rent, because now we have a much higher chance to get a low type. And this is exactly set up of, and this is not some specific assumption, but a rather general property called separation property by Lafortiro. Okay, so I think I will try to explain it, and there are two slides left, and I would like to present them today so that I can conclude this chapter. So I would like to take another, say, hopefully 5 minutes in this discussion. Okay, so here the point is, of course, in this story with this franchise allocation, we get some problems once we get to real world applications where we have franchises, as you just previously saw, for 15 and 20 years. Okay, how long should it be and how often should it be renewed? The problem is, in these franchises, you need a lot of investment in rolling stock, which is a durable asset. You have to buy new trains and so on, new engines, etc. And this requires, in a sense, that you can have a long planning period. Okay, and of course it's then very hard to specify all these prices and services into the future. And the point is that typically the incumbent has some like Deutsche Bahn did run all these services, and they have an advantage in terms of that they know the real cost, for instance, or they have a much better idea about what ticket revenues will be, and so on. So the problem is, you might want, I don't know, do you want to bias it really act in favor of the incumbent so that it makes more investment, but then you never get an entrant? On the other side here, the entrant may suffer of the so-called winner's curse effect, because if the entrant wins, perhaps this is due to the fact that it made wrong or had wrong expectations about, for instance, ticket revenue. Actually, there's an interesting example in Germany, the Nord-Ostsee-Bahn, which obviously underestimated the cost of the connection between North Sea and Baltic Sea, North Sea and Baltic Sea. Somehow they won some franchise, but it turned out that they went bankrupt within 2 years or so. Okay, so it's even though it's an amazing instrument in order to introduce competition for the market here, in practice it's a problem, but that doesn't mean that you shouldn't have something like that. Problem in Germany is currently in a sense that very often you hardly get 2 bidders, okay, for large franchises in terms of railways, for instance, S-Bahn Berlin or something like that. Okay, the final point here is the rent-reducing effects of joint production. I can make that very brief. Nevertheless, it's very amazing, because the question is here, if you have railway franchises, for instance, the connection between Frankfurt and Siegen, the connection between Frankfurt and, I don't know, Darmstadt or Mannheim, connection between Gießen and Gelnhausen, and so on. There are many of these connections, so many different tasks. And each task might be indifferent, because the costs between Gießen and Gelnhausen. So here, it's independent, not indifferent. Okay, these are independent tasks. So the costs are between Frankfurt and Gießen are independent of the costs and not correlated with the costs of Frankfurt and Mannheim. Or Hanau are completely independent from the cost between Gießen and Siegen, probably, and independent from the cost to the connection to the Odenwald. Okay, and the point is, how should you regulate that, and how should you assign contracts? Should you assign them to many different suppliers, or should you all assign them to the same company? And here actually you have something like a portfolio diversification argument here. Here you have an argument where you see that there are informational economies of scope. If you have many products, okay, and you have many different products, each with unknown marginal costs, and costs are independently distributed, so no yardstick possibilities, then what you should do is just award all the different tasks to a single firm. Why should you do that? Now, if it's really many, you have the law of large numbers. You know, with 50% chance, with these 100 different franchises, with 50% chance, each of these franchises is of high cost and low cost. So if you have only one franchise for each firm, you have a very large problem, because it's a large uncertainty. But if you have 100 of them, you know that on average 50 of them will be high cost, and 50 of them will be low cost. So you reach almost perfect outcome if you set a price and the transfer equal. So the firm sets a price PI, and it receives a transfer equal to the consumer surplus. So that is, it simply maximizes total surplus. Okay, and what you're doing here is that total surplus for this aggregate, if you have really 100 or more tasks, it doesn't vary very much. Okay, that's what I just told you with this 50%. You know that 50% will be high price, high cost, 50% will be low cost. Okay, and so you have a clear picture of that. And what you're doing then, you get all these transfer, and then of course at the same time you get a tax which is almost equal to the expected value of these expected profit here, and you just leave an epsilon so that it's clear that it can break even. And what you have is that the firm is left with almost no rent. Okay, and of course, clearly this is superior to a policy when different firms supply the different products, because in each case then you have to make sure that the participation constraint of the low type is of the high cost type is guaranteed, and that the low type might get the rent. Okay, so the interesting thing is, should we have many different railway companies with these things here? Yeah, actually that claims for more, or that you should not have in the Rhein-Main-Verkehrsverbund 25 different companies, but you should have large lots in a sense. So if you want to assign it to several companies, make sure that they are sufficiently large that they have this portfolio effect. Okay. I think that's about it on this chapter of information and multiple firms. Again, we will have some assignments on that, so that's why I went through it in a sense rather quickly. But here it's really to get the ideas right. So you saw we just applied the standard kind of analysis we already did previously. We had this Baron-Meyerson model, and what you really should have as a takeaway is that with these auctioning, with these franchises, the point is that you get this rent reducing benefit and sampling benefit. And the interesting thing is that at the same time, these competition for the market with multiple contestants increases the probability of having a high type. That leads to the point that you have to pay a higher rent, okay? And at the same time, it reduces the rent. So in these two effects balance, hopefully, yeah, should be somehow clear, hopefully. And I think these are just wonderful full extensions of this part, and you'll see how really competition can work even if we don't have several firms being active in the market. Yeah, that's about it. So, and I tried to also show to you that these are empirically relevant policies in a sense. And we will turn to even more empirically relevant policies, of course, in this part on practical policies, where we will delve much in more detail into what is called tariff basket or price cap regulation. Okay, I'm done. Again, I have to apologize for taking more time from you. Hopefully it was okay. We are still running a little bit behind, or not really behind schedule, but there's one week missing in this semester, so you had to accept 10 additional minutes. Hopefully it's okay. Again, I'm available for questions in Webex. I thank you for being with me, and see you next week. Bye.
Okay, the big advantage from doing this digitally is that I can speed up myself, and so that way that I'm on time. So thanks again for being with me. I'm available, of course, for questions right now, and see you next week. Bye.